here, there's a bunch of material either on the Git repository or you can access it directly through the web page. Just click on some of the links. This is in varying states of completion. Okay, I'll say every time I do this, I don't know why, but I always start with a brand new set of examples. In your case, I try to show some of yours. Okay, just kind of kill two birds with one stone. Some of these, there's code for a bunch of them. So basically, here's what I'm trying to do today. Is just wait. I have this attractive book, for example. And the reason I show you is this has got a lot more to do than just web scraping. It's all to do with XML and data technologies. But that's the thickness of this stuff. You can go on for weeks on this sort of stuff. And we got 2 hours. But so I basically want you to get the concepts. Okay, this is just about web scraping and APIs. Just figuring out what all these pieces are. Everyone knows about HTTP. I'm not sure everyone knows, what it does and how, and basically what the elements are, and HTML and all these different things. So basically, just figure out what the landscape is, when to use, where they're being used, when we have to deal with them, and how. Okay, there's a couple of tools, a growing number of tools. This is all, we're going to do this all in R. It's got very little to do with R. There's nothing here to do with R. Okay, this is Python, R, MATLAB, any language you want will basically have tools to manipulate the content we're talking about. Okay, and if not, go find another language and off you go. But basically, these are general tools. Okay, and then a big part of this is actually just what's the strategy. When I look at these things, I go, okay, I know how to do this, and a lot of it is very specific to a particular website, a particular web page that you're actually going to get to. Okay, and that's the problem. Okay, this is where, because one of the things, importantly, that I hope what we're trying to do is we are trying to automate the extraction of data. Okay, we don't want to be doing it by hand. We don't want to be sitting there clicking through a bunch of pages, cutting and pasting. We actually want to be able to reproducibly collect data by going back to the same page on a regular basis, or collecting a whole bunch of pages and actually extracting the data out. Okay, so this means that it's reproducible, it's scalable. Basically, if I ask you to cut and paste data from 100 pages, I would pretty much bet that you will fail to do it correctly, okay? Because it's really, really boring. So we want to automate a bunch of this stuff. Quick thing first, okay, and if you click on some of these links, I've just written a short couple of paragraphs on some of these. What is scraping? Okay, scraping with one P. Okay, scrapping is a whole different ballpark. Okay, by scraping, we're basically talking about taking stuff, extracting data out of web pages that are meant for humans. Okay, with APIs, the content is not intended for humans. It's intended to be consumed programmatically, and as a result, that's what we want to go after every single time if possible. Okay, when we look at a web page, this is blue with an underline under, okay, whereas we know it's a section. There's structure to this, whereas when we actually look at it, and when we actually look at the HTML underneath all this, that has all gone away. We're now looking at blue things, and we've got to actually connect blue with a section header. Okay, look at the font and stuff like that. We basically always want to actually try to find ways to avoid scraping. It's kind of a little bit odd that here we are, we're talking about scraping and APIs, and all I'm basically saying is don't do it. Okay, I do this every single time I give this talk. Don't do it for various different reasons, and these are really important. There's technical details that we have to go through, but there's important things from a software engineering point of view. You're writing software, if you're going to automate this stuff, this is highly unstable. Okay, I write code to pull data down off the New York Times. Okay, we'll find out how we do this so that you find patterns that you're looking for. You go back a week later, they change the way they represent the actual rendering on the page. Same structure, same content, but slightly different underlying HTML. My code is now broken. Okay, this is highly unstable. Okay, it's amazing it works all stable for a year or two. It's wonderful. The other issue is this, okay, and this is an important one. You're probably not allowed to scrape the data that you're trying to scrape, okay? And who cares? Okay, well, some people care, okay? You can get a cease and desist most importantly, if you actually start banging on a web page or web server, okay, if they have mechanisms that most good web servers will actually recognize that you are not a human, okay, that you're doing this too fast. You're reading thousands of pages per minute or whatever it is, and then they basically then they start throttling you back, or more importantly, what they do is they ban you. Or more to the point, actually, very specifically, they ban your IP address and often the entire sub-network that you're on. Which means if you're in the library, for example, and you go and start banging around at the New York Times or something like that, and they ban the entire library, you're not going to be very popular if anyone figures out what you've done. Okay, but typically you're not allowed. First of all, you have to rate limit yourself. You're not allowed to make thousands and thousands of requests per second because you're putting too much of a strain on those servers, especially for some small non-commercial servers who are providing open source data. The other thing is they may ban you. Okay, you're not allowed to take their data and then give it to other people. So you're not allowed to go and sort of get the feed of the New York Times with your subscription and then start posting it on your website in real time. Okay, clearly that there's a business model that's broken there. Okay, so then they will actually come after you. So you have to be careful of what you can do with the data. You've got to be careful whether you're allowed to scrape it. If you read them, and nobody does, okay, the terms of service that you actually sign up for, if you have an account on Twitter or something like that, you can use that account to, they say you cannot scrape. You can't scrape Craigslist. You can't scrape lots and lots of different things. And some companies get very concerned. Okay, so be very, very careful. The other thing about it is, and this is also kind of funny, that's just like, here we are, here we're going to talk about all the technical stuff, is if you can avoid scraping, avoid scraping. If you can avoid APIs, avoid APIs. If there's gigabytes of data, do not go and pull it down off the web. It's extraordinarily slow. Okay, and it puts a big demand on the servers up there. Ask the people who own the data, can they give it to you in bulk form? Oftentimes it will be available in bulk form, where basically you can just download massive files, okay, a big database or whatever it is, and that's the best way to do it because it's structured. You don't have to write any code. Now you just basically pull it in. So don't overlook the obvious. It's actually easier just to go and try to find a much more sane, less technically challenging way of getting the data. So one of the postdocs here just was looking for this. Was about to pull a lot of data from one of the California government sites. There's going to be a lot, and he knew this was going. So what do? We just send them an email. And they say, okay, I tell you what we'll do. We'll send you some DVDs of this stuff out. Okay, so they send 5 DVDs. It's over. Okay, the U.S. Postal Service still actually moves the most amount of data around. Okay, so try to avoid scraping. Try to avoid. If you can use APIs, great. If you can get the data in another format, great. Just scraping is the worst thing you can possibly do, and yet that's what we're going to do. Okay, so and that's fine, but always look elsewhere. As I say, ask lots and lots and lots and lots of questions. I've been doing this for far too long, and
are there any serious legal implications for scraping or just banning?
Serious, yeah. I mean, if you've signed it, in many cases you've actually signed a contract. You clicked on it. You actually clicked on saying yes, I accept these terms when you actually got an account. So there's a lot of different. If you're anonymously going to a site, so you're not using your own account. There's no account. You're just going there. Then they can be upset with you. But you actually have kind of implicitly said, I agree to the terms of service. If you use an account, then you actually have a signed agreement with people. Okay. Now, none of you have ever read the terms of service, I assume. Okay. At least I never do. Okay. But you have actually done this, and you want to be very careful. The biggest concern that everyone has is when you actually take their data and you actually essentially put it into your own app or something like that, your own web feed in real time. People don't like when you scrape the data and do analysis on it, but they're okay with that because there's no commercial gain there. Okay, what they really are concerned about is basically you just pilfering all their data in real time and providing a different front end to it, and hence getting all the advertising dollars and all that sort of stuff. But generally, you do have to be somewhat careful. Okay, and there are legal implications. Okay, so that's the caveat of like, okay, don't do this stuff. Don't do this stuff, but we're going to do it anyway. Okay, so off we go. Okay, I teach this in various different ways. Okay,
First of all, the world has now moved to HTTPS. Okay, there's nowadays we want to use secure HTTP rather than regular HTTP, and that now makes my life a little easier to explain in some regards. Okay, basically, let's go here. Let's go. This is going to bring me to. Hello. Let's go to this web page. There's no good set of examples. I have so many in this book that I don't know which ones to pick, and I'm sort of trying to pick them only for pedagogical purposes. This is a web page. This web page has been around for years and years and years. Okay, this is the consumer price index, the inflation index. Okay, and for basically, and we look at this, and again, look at this. I wanted a data frame with this. Okay, with this information in it. This is essentially a table. It's a structured data set. Okay, we've got all this nonsense over here. I've got an ad for a cell phone. I got all sorts of nonsense that is completely and utterly distracting me. And I've basically got to work around all of this sort of stuff. I want those values. Okay, now again, you potentially could cut and paste this in. You're going to get radically different results based on what your browser is and what your operating system is and your configuration and whether it gets the character encoding correctly and so forth. Then you're going to cut and paste it into a block of text and then move on from there and sort of massage it in some way. It is very, very structured here. So I want to actually get this information from that web page into R or Python and be able to plot it, for example, or be able to use it to adjust some financial values. So this is the consumer price index. How do I go about getting this? That's your task. What are you going to do? Suggestions? I'm taking cut and pasting off the table. And you're not allowed to type it in either. Okay, and by the way, later on, we'll get there in a second. I'm going to change this. If you're feeling that you're happy to type it all in, okay? This we can go all the way back to 1913, 1914, okay, and now you've got a lot more data to actually plug in. Okay, so we need to connect to this. Oftentimes we're going to go through pages and pages and pages of data. So how do I get this data?
In Python, you could just use like the requests module and use request.get.
Okay, so but that's not actually going to get it into the form that we want. So that's one of the critical things. We've actually got two steps. Yeah. Trying to get it from HTML. We're good at what we actually want. Okay, so what do we want to do? We've got okay. So basically, this is the cloud. Here's a web server. Okay, this is all hopefully straightforward elementary. Okay, if not, let me know. Okay, and this is our web browser. Okay, this is our web browser. But I'm also going to put in down here R, okay, or Python with different modules in Python, whatever it is. Okay, okay. These are clients. Okay, so these are clients, and you know what? We don't care what these are. The web R and a web browser are totally different beasts, but when they're all capable of actually making requests. Okay, there is an HTML page over here. Okay, there's an HTML document. Okay, so we actually have a document over here. Each web server probably has thousands of documents that it's serving up. We needed to actually, in browser, when we actually did this, we went to the we clicked on the URL that brought us to here. Okay, and something happened, and we just rendered the document. What's actually happening is the browser goes off, and it makes a request. Okay, it makes a request for the particular URL. It says, it figures out in the URL that this part here is the address of the server. And then everything after this, okay, everything after this is the path in the server's file system to actually tell which document it wanted. Okay? So it made a request, and then this guy came back with a response. We're going to have to mimic this, okay? It's not a big deal. Okay? We have a request and we have a response. Okay, and that's about it. And now, just for fun, we'll see in a second. Okay, each request is basically made up of two things. It's got a header and it's got a body. And the response has got a header and a body. Okay, they're kind of, it's nice symmetric, some nice simple thing. When we get the response, the body is the HTML document, the actual text of the file over here. The header is actually, the response tells me that it's HTML, that it's this long, it's compressed or it's not compressed. It tells me information about the body, okay, and about the request, whether it was successful or not, okay, and so forth. In the request is basically, we tell it things, okay, about our request, okay. The URL tells it, here's the machine, here's the path in the directory over here. But we also tell it, oh, by the way, I'm R, or I'm in Firefox, or I'm Chrome, okay? Because the server can actually respond differently. We might also include other information, like I only accept HTML. Do not give me compressed HTML. I do not want an image, okay? I want PDF, not a PNG. I can tell it all sorts of things, which is in metadata about the request. 99% of the time, you're going to find out, 90% of the time, okay? You're going to find, for the request, there is no body. Okay, it's nice and simple. There's no body, there's nothing in the body, it's an empty body. Okay, all the action is in the request header, okay? And that's, okay, we'll see that there are counterexamples of this and they're kind of fun, but for web scraping, it's going to be approximately that. Okay, it's going to be a lot of what are called get operations, which means there's no body, life is very simple. So the thing we need to actually do is the following. Okay, can you change this? So I'm just, for those of you who are used to using RStudio, this is R, it's the same as RStudio, there's no difference, it's just kind of in my own little world. Okay, and I'm very uncomfortable in it if I'm not in this world. Okay, so this is just R. So there's two steps here, okay? Okay, we wanted to get the table, just let's see it underneath, the table under here, we're going to get the values into R. This is going to involve two steps, okay? Okay, and the first step is make the request, get the content back, the actual contents of the HTML document. The next step after that is going to be to actually extract the values from the table from that document. So the two very different things is get the document. Now it's local to our machine, and let's go and manipulate it. Okay, so the first thing we do in my world, there's various different packages for this now. This is 20 now, almost 18 years old. Okay, but it still gives you an enormous amount of flexibility. One of the things we're going to do is the following. Where I am going to go and hang on a second. I just need to find myself, this is inflation. So this is the code that we will run. Okay. So that's the URL. Okay. Here we're just basically specifying it, and now and all I'm really going to do is here I'm going to say, go get the content for this. Okay. And what I'm going to do, I'm going to actually just change this slightly because I'm going to say, by the way, show me what's going on, please. Okay? And what this is going to do is that. It says, I'm trying to connect to 774. This is the IP address corresponding to this machine. Okay, then it goes and it says, yes, okay. Then it starts negotiating. The point of HTTPS is twofold, okay? Rather than regular HTTP, the S in HTTPS stands for secure, okay? And the security goes both ways. When we connect to a machine, we want to actually have it verify that it is the machine we think it is, that it's not a fake. Okay, so when we go to Twitter and it's actually run by somebody else, we want to actually be able to detect that. So that we have certificates that are signed and we can check that. And then in addition to that, we actually also can say we are who we are and verify that. And also we can encrypt all the communications so nobody else can eavesdrop. Okay, that's what the security is going both ways. The real important thing is that you not connect to a machine that is not actually verified as being who he said it is. So here's what we're getting. This says I'm making the connection, and now I'm going to get this HTTP, this hypertext transfer protocol has basically 9, but we only care about 3 different actions, 3 verbs, and then 90% of them are going to be gets. Okay. and we say, get me this document, please. And it says, okay, fine. This is the header that we actually send. Okay? It says, oh, by the way, that's the host. We'll accept absolutely anything back. Okay, we're not picky. Okay, and we don't. And here we do not actually tell us that we are Mozilla, Firefox, Chrome, and we do not tell it who our user agent, which is bad. We should. We really should. Okay, and then this is the response. This is the header of the response. It says, yes, here's the status, 200. We all like 200s. That means it was successful. If we see a 400, it wasn't successful. You won't see a 300 in your browser because 300 means redirection. It's going to actually bounce you somewhere else and eventually hopefully work. But this is the metadata from the response. It says, here's the type of content, HTML, okay? Blah, 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 blah. Yeah, who cares, okay? It even tells us what type of software the web server is running, okay? Do we care? Not really, okay? But at the end, now, all that's happened is, and if I take a look at this, what is the class of TT? This is the thing I assigned the value to. And let me just take a look at this. We'll take a look at the first 1,000 characters in this. And that is what we've gotten back. We've got back the document, okay? So there's 2 steps in everything, okay? Get the document, however, okay? This is the HTTP request, and that can be very tricky, okay? We may play a lot of games. Once you've got that, then we're going to actually parse it. We're going to process this and actually go find the text. Just to be clear, let's look for 15.9. Grep, this is just simple text, so I'm going to look for that. Okay, in TT, do I find it? Yes, I do. It's in there. Somewhere in there, it is there. Okay, everyone happy with this? Straightforward HTTP. We've done exactly what the web browser did. It's just we did it programmatically. The web browser points and clicks and then displays it. We couldn't care less about displaying it. Okay, but the nice thing about this is we can now talk to web APIs the same way, where the web browser won't. Okay, we're able to make any HTTP request. Okay, any questions? Okay, I don't know. Okay, so we solved that problem. Okay, we've got the URL content, and again, there's different packages. A package called curl, there's rcurl, HTTR, other different packages. They're all doing the same thing. They're all pretty much built on top of the live curl piece of software. Okay, we can do this on the command line too. We're doing it in R because we actually want more flexibility. Okay, how do I get? This is a trick question. How do I get the values out of this text? This is just text. The HTML is text. The web browser grabs this text and then figures out how to render it on a page, okay, with all the links and everything like that, and all the images and so forth. How do we get the text out? The goal is to get it into a data frame. Nice table with rows corresponding to the rows here, columns corresponding to the months of the year. Then we rearrange it and plot it. Okay, so you got, if I forced you to do this, how would you do it? I know how you would do it. How would you do it? That's the process. Yep, you could Stack Overflow, absolutely. So, okay, so you go off and find that because someone solved this problem before. Okay, absolutely, okay? So, but the immediate knee-jerk response from many people is, aha, I'll use regular expressions, okay, for pattern matching. For those of you who don't know about them, good for you, okay? But because this is what you really don't want to do here, okay? What we've got is a big piece of text. I actually said, go find this pattern in here. Even that was actually not quite right. That dot gets interpreted in a different way. It's not looking for a period, it's looking for any character. So it could have found 1589, and it would have been a match too. But this is just, we're doing regular expressions here. And all I was doing there was just to say, can you actually find this piece of text in there? Have I got something right? Okay, yeah, but I do not want to go through here and actually look for what we're going to have is, and let's just do this, okay? What we actually have, and this is, let's take a look at this, and I have notes. There's notes lying around on the website and in the Git repository. What we've actually got is this. Every HTML document starts off with HTML. Okay. Okay. a line because it actually starts off with a doc type, but we don't care about that. But we see this HTML, you see that less than and a greater than, and then it has a head with a less than and a greater than, and you keep going down, and somewhere down here, which I can't see because it's too complicated, and I didn't get enough of this, so hang on a second, let's take a look at this. Okay, and okay, so trust me, you can't see this because it's hard, because it's just a big block of text. And to minimize the transmission cost of the actual transfer of the document, they compressed all of this down with no white space and all that stuff. It makes it clearly unreadable. But there's a less than, a slash, and an HEAD. Okay, and that ends the guy that started it. Okay, that head is ended by a slash head. Okay, so this is important, simple. Okay, so basically what we actually have is under HTML we have a head. So these look like this. Okay, blah blah blah. Okay, less than, name, greater than sign. Okay, and over here we actually happen to have a body. Okay, kind of like the request, we have a header and a body, just merely a coincidence. Okay, slightly darker marker. Okay, again, this is hopefully. I hope none of you have seen this. Again, like you all have in some regard. So underneath here, we might have something like a title. Okay, we might also have a script. Okay, we might have a script. We may have many of these. We may have metadata. The order is probably not that important. Okay, every single one of these is ended by a slash title or a slash script. Whenever we start, we're supposed to end. Now the HTML actually, that was too hard for people back in the mid-90s. So we became very, very lax about doing things. So we don't actually, it doesn't quite work out that way, but that's the model. Basically, what have we got here? So over here, we might have something like a paragraph. And we have text and markup with maybe a bold, some text here, some text, regular text. Then we have a bold tag, B for bold. Underneath here, we might have some text. Over here, we might have an italics. Underneath the italics, we may actually have some text. We may also have an A here, which is a link, an anchor for a hyperlink onto the web, and some more text. And we may have a bold over here. This is an arbitrary tree, if you will, okay? Every node starts with a less than, the name, and this greater than. This is the start, and then it has a corresponding end, and everything underneath, in between that, are children of these nodes. That's why I'm drawing them as a tree. This is the root node. These are the two children, okay? There's nothing else. Underneath the head, we actually have multiple children of head. Okay, so if I took this as the root node, it's the same thing. This is just got children. Okay, and these guys, this node has one child. This node has 3 children. This is recursive the whole way down. Okay, it's basically very, 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 very simple structure. Okay, and that's what, but it's incredibly general. Okay, so what have we got? We've got nodes. Okay, they have a name. Each node has a name. Each node may have children nodes, and they are nodes, so they have a name, and they may have children. And the one thing I haven't shown you, which we will see here, is this. Pick one. Okay, here's a script. I told you we got a script. This is for JavaScript, okay? And then we have these things. I kind of lied to you that we said it starts with a less than, then we have the name, and then we have a greater than sign. The greater than sign is actually here. And there's stuff in between, and they are of the form name equals value, name equals value. And these are called, okay, and again, why do we need to know all this stuff? You, okay, a node may have attributes, and these are just name equal value. Okay, everyone happy? Yep.
Those backslashes?
Those backslashes are because R is showing you a string and it's got quotes inside it. So let me get rid of those guys. This is because, so let's just do the following. What backslashes? Okay, this is ours weird thing. So if I do the following, if I do just this is okay. That, everyone happy that this is a string in R that consists of one quote. And the way R shows this is it always use double quotes, and therefore it has to tell you that this quote, the middle quote, the content is actually escaped. So there was no slashes in there at all, okay? It was just the way R sees it, or it displays it. Everyone happy? So you could write a regular expression now if you understood enough HTML. The thing about HTML is it's, okay, let's just decide here, okay? HTML, okay, it really has this structure. HTML, head, body, and then it has a bunch of terms like P for paragraph, okay, I for italics, B for bold, A for href. It's a fixed vocabulary, okay? Okay, there's just a finite set of things because you can't just start making nonsense up because the browser doesn't know how to display it. However, the browser will still work with it. There's another language called XML. You'll see this also lying around the place, okay, for web APIs especially. XML is called extensible markup language. It's very similar to HTML. It's got exactly the same structure. That's the beauty of it, okay? Exactly the same. We have nodes, we have attributes, we have child nodes. The thing about this is the actual names of the nodes are completely arbitrary. So what we actually have are dialects for specific purposes, but exactly the same structure, which means we're going to use exactly the same tools to actually deal with XML and HTML. Okay, this is the thing we do, HTML parse of TT, and we just say it's a document, okay? First of all, I got to actually load the library. Okay, the XML library. There's also the XML2 library and other libraries now. Okay, so we parse this. What that has actually done is it has taken this big block of text, which is just random text, by the way we look at it, and it has turned it into a tree. Okay, it's turned it into a tree, and now we can actually process it with structure. Because now I can actually find elements named B, not go and look for the character B that is preceded by a less than sign. Everyone happy?
Where do you find this?
It should be. Is it not on CRAN? It's in this. Later. just go along conceptually with me. It's on. I'm putting you on the box. Okay, so what we've got conceptually, we've got a tree. Okay, so it has actually got structure. It's no longer text. We're not looking for actual characters in a row that have a certain pattern. This makes life an awful lot better. Okay, you have to know what the vocabulary is. It turns out that people who wrote HTML actually sort of used terms we can probably recognize, which is, and actually just to be clear, in our web browser, we are going to actually go and look at this is the same HTML that we got back. Okay, if I want to, let's look for 15.9. Okay, that's one of them. Okay, it wasn't quite the one we wanted, but this here, oh my God, look at this. Well, okay, that is probably the table we want. Okay, and it's a table. Okay, this is the name of the HTML elements, and these are the attributes. An awful lot of the we're now finally using a thing called cascading style sheets, CSS, and these we use classes and other things to actually control the appearance of the HTML. Okay, using a class and other different things. This is two classes. This is an attribute. Okay, then we've got a T body. Okay, we just have the table body, T body for table body, TR for table row, TH for table header, TD for table data, and within all of these we've got the values. So what we've actually got is somewhere down in this tree, somewhere in this big tree, with all the ads over here and the other links over here to all this nonsense, there is going to be, very bad colored pen, okay, we have a table node, we have a T-body node, oftentimes we have a T-head and a T-body, and underneath here we've got a bunch of TR nodes, and each TR node has a sequence of children which are THs or TDs, okay? Very, very structured. In fact, so structured and so common that what we're going to actually do is we're not going to do anything with this. We're just going to say, hey, because somebody wrote this already, which is just go, just give me the, just go read all the tables in this document, okay? We're going to find out how to do that very fast, okay? So this is a high-level function that's built on something that we're going to actually look at soon, a thing called XPath. If you wanted to, just to, okay, we'll get there in a second, but okay, but basically what you have to do is you start here at the root, that's everything you've got, and you will go down and say, give me the body. Okay, in the body, go down and look through all its children and see are they tables. If not, look through all of those guys, and look through all of these guys. Oh, that's going to be really painful. Okay, we're going to have to recurse our way down the whole way. How many of you like recursive functions? Very few. No one likes recursion. Okay, so it's a little bit tricky. So there's a nice tool that'll actually allow us to do this much more efficiently. But here, this is what we got. Let's take a look back. If you are lucky, you are done here. Okay, basically, if your data that you want to extract are in tables in R or in HTML, you can just basically say read HTML table, and it will give you back data frames. Most of the time, okay, because people are very bold the way they actually display stuff in HTML. It may be very badly structured. So then we got one table back. Okay, so let's take a look at what this is. What's the class of this? It is a data frame. Yes. Okay. What else is it? So let's take a look at the dimensions of this. Why am I having so many difficulties today? Okay, it's 12 by 14. Does that look about right? If we go back. Yep, good. Okay, excellent. Okay, you have 12 rows, 14 columns. We only have 12 years. The 12 rows are not the 12 year, or the 12 months, should I say? So let's actually take a look at it. It's nice and small. So let's take a look at the very first guy. Okay, and that's what we actually have. Okay. Yeah. So that's what we get. Everyone happy? Yep.
Yeah, I mean, troubleshooting the breaks at the end of the seminar.
For troubleshooting on your computer?
Yes.
Yeah, yeah, don't worry. Yeah, just, life's always fun. Everyone happy?
Once V1, the numbers just name titles for vectors. So
if a data frame doesn't have names, R will give them call the column name V1 up to VN, VK. Okay, that's okay. And yet we did not get the right answer. These should have been the names, okay, and then this should have been the first row. So we kind of off by a little bit because we saw that it had a T body, it didn't have a T head. Every table should have a header and a body. They don't. Live with this, okay? This is okay. So one of the things we can actually do is we can go back and say, you know what? Trust me, I know better than you do. Okay, you can't find this header, but I'm telling you it's there. Okay, so now we look at this guy, and now we've actually got we've said the first row is the header. This is like read.csv with the header equals true or false. Okay, you've told it enough, and now it's actually gone and done what it should have gotten. Notice, by the way, and importantly, I didn't go back and get that document again. I already have it here, and I've already parsed it. I'm completely separated now from the web server. Okay, I can go back and get the document later on, and life is good. Okay, everyone happy? Any questions? There's a piece of magic that actually makes this all happen. Yeah.
Well, there are scripts in the web page that are executed, and we get the web page before or after execution.
We're going to get to that later on, and it's a royal pain. So, but to paraphrase the question is, we're all now completely enough, and we've got our phones, we've got all this, okay, we've got all these browsers. The world lives on JavaScript, okay? So you get an HTML document, and we saw these script tags. Well, they actually have code in them that gets downloaded with the document, not quite, but alongside the document in a separate request. And then the browser then actually, as it's rendering the page, it actually runs that code to help it render the page in a customized way, okay? So who does the rendering and running of that code? I just said the browser. Where's the browser in this? We ain't there. Okay, so We are getting back the HTML, and that's it. In fact, actually, what you'll see is that most of these guys, we actually saw it here, which is, if we don't go take a look at this, this here is, these two scripts are quite different. This one says, here's the code. This one says, here's a reference to the code. So it doesn't even actually contain the code. So your browser will actually go off and make a separate request to get this block of code. And if you have images in there, you have to go off and get the images separately. We'll see it, and we'll see it soon, where you watch your browser, you ask for one document, and it goes off and downloads about 1,000 documents. Okay, all one after the other, and tries to do it as fast as possible. That's why we minimize the text. Okay, so but none of this code is getting run because there's no browser to run it. Okay, now we've got a problem. Okay, and now we've got to be quite strategic, because if the data that we actually care about are dynamically generated through JavaScript, we got to have a different strategy.
So I found that all of them are being saved as characters.
Which?
These numbers.
Yeah, well, that's enough.
STR, I found that they're all being saved as factors. Is it usual, or have I done something wrong?
No. So if we go, so now we got a data frame.
Yep.
Okay, so let's take a look at this table of one and look at the class of each of the columns, and it's a factor. Okay, a lot of the times we can say back over here, we can say don't do that as false. Okay, so now we do that just like we do for read.csv, and now we get characters, and now we've got to interpret these. Okay, now there's functions in R to interpret these. And there's functions also with the read HTML table that actually go beyond what R does, which is to recognize things like dollar signs, commas, and percentages, and actually convert them to numbers. But to do this, you have to take control and say the column classes are these, okay, just like you do for read.table, okay, because no one can interpret these, ahead of time, because there is no metadata describing them.
If you do an STR on that table one.
Yeah.
I find that all of the, I think I get.
Yeah. So we just instead of str, instead of looking at the structure, I'm just asking what the classes are. They're all factors here. I've turned them into strings, but now you have to interpret them. Okay. And this is the same as a read.table or read.csv. If do you need to turn them into dates or whatever it is? It doesn't try to guess. Okay. Because typically it is context specific. Okay. Everyone happy? I need to remember. Okay. So here's what we're going to do. I think. Let me just check what order. I changed the order I was doing this in. So just before I start going. So we got the tables. Mm-hmm.
Very easy question. Do you think with the columns with the months, can you do that in an easy way with the row names and years? Is that a
we could. So. These we can post-process this, okay? Okay, we can do whatever we want, but now we're totally in R, so it's unrelated to the website. It's this function, the read HTML table. You can throw it away and just do everything yourself if you have contextual knowledge, or you can just let it do this and then actually rip the things apart. Okay, you can definitely pull these guys out. For me, I'm probably going to want to turn this into long form, in which case I'm going to actually read the year as a column anyway. But maybe you want to keep it in whatever way you want. Okay, but now we're back into R. Okay, so you just manipulate it however you want. Okay, so before we actually figure out how to do that, okay, and this read HTML table is actually kind of useful if you something else. I believe we may need for another application if you actually go here. This, oh, for crying out loud. Pardon? I'll get there in a second. Okay, so this is another example. Okay, so we actually want the zip codes. We want the zip codes of everything in Texas. Actually, I want them for all 50 states. Okay, I want to go and pull these guys down. Okay, there happens to be a web page. Hopefully this is correct. This is the other big thing. You've got to check to see the data you want are actually the ones you want and they're actually reliable. Just because we can scrape them doesn't actually mean that they're correct or useful. So we can actually go and we can go and do get the contents out of this. Again, if things work this way, life is very useful. You know, it's nice and simple. We'll just go down to here. Where were we? Do I not have this anymore? Ugh. Where was I looking at that? Sorry, let me just grab this. This is a particularly annoying page. People do this all the time. Okay. So this here, what we're going to do with this is we're going to say yes, there's a header because you don't know. Which equals 2 says there's actually 4 tables in here. Okay, and I only want one of them, and the header only applies to one of them. So I can basically say only read the second one, or I can actually give it a name. If it has a name, I can actually identify it by name. Okay, and now we go off and we do this, and it thinks for a while. So the which gives me allows me to, because we read HTML table will read every single table. Some of them may be too big, some of them may, you know, that we get no interest in. This allows us to zoom in and actually go. Okay, what's really annoying about this, and if you take a look at it, about that page I just showed you is, when I looked at this, we have 4 tables, I only see 3. The first table is actually a table that contains the big table. Okay, for some unknown reason, because people do this to actually get things to appear properly on the web browser, which is exactly what we don't, has no structure, no content to us. Okay, but it makes life confusing for us. So if they ever fix this, they'll get rid of that table, and now there'll be 3 tables, and I'll be reading the wrong table. So this is why things are very unstable and unreliable. Okay, let's go back to this thing. Okay, so I haven't really told you how to actually get the HTML content out, except for if it's a table, read HTML table will hopefully do things with it. That's good. Let's go back over to here. Where is it now? It's not that guy. Let's go back over to here. Remember we saw this? Remember we saw you could actually pull out different years. Okay? Okay, we can specify this. How do we do that? What's going on here? Okay, so this is actually, this gives us a lot more flexibility. This is a huge leap, and it's actually very, very simple. We're going to actually do the same thing. What we did is we actually selected a year here, and then we clicked on this button. Okay, do you remember? And then if you go up to here, you'll see in the navigation bar, you'll see it goes to exactly the same, URL, but it tags this thing on here. Start year equals 1914, and end year equals 2017. You'll notice here there's a question mark, and there's an ampersand between this. Okay, so basically, there's an HTML form in here. This is interactive, we point and click, we fill in text fields and so forth. We click this button, somehow it gets submitted, okay, as an HTTP request. And it collects up all of the named elements here and their corresponding values. So somebody who wrote this page actually called this text field start year, okay, and this pull-down menu, and this pull-down menu is called end year. Seems like a perfectly reasonable thing to actually do. And then basically, the browser collects these up and dispatches the request. There's still no body in the request, okay? It sends stuff across, okay? And the URL now contains the parameters, okay? The arguments, the user inputs, and this is good news, okay? And we get the response back, okay? So what you could do if you wanted to is you could actually go and paste this together. You could actually construct this URL yourself in R, okay? And that would be fine. You have to know the start year and end year names of the variables. How do you do this? Okay, well, one way is just click and see what the thing shows up in the navigation bar. That's actually not going to be enough in many cases, but it's a good start, okay? So if we actually, but the one annoying thing is if I actually had, for some reason, if I was typing in text here and I had a space in there, you would actually see what would show up would actually be %20 in place of the space, okay? If I had an ampersand in the text field that I was typing in, I can't put that into the URL because the ampersand means separate this variable from this variable. So I'd actually have to encode the ampersand as being, you know, a piece of text, not a delimiter between the parameters. It gets ugly and nobody cares and nobody wants to deal with this. So what do we do? What do? We do the following. We can basically do the following. So this was you.
Okay, this was our URL. We can go back to this and we can say get form. Here's the U, and we now say start year equals, and we'll put down 1913, and we'll put down end year equals, what was that, equals 2010, let's say, because maybe we only want that. And now we'll get back our document, okay? And if we want, we won't actually do that if we want, okay? So it goes off, and now if I say read HTML table, we're going to assume, well, we have to HTML parse this guy. Okay, we have to turn it into a parsed document, hand it to read HTML table, and we're going to say which, well, we'll just say strings as factor, well, we say header equals true, we'll just leave it at that. Okay, get it right, okay, this is TBL2. And now if I look at head of TB, oh, well, what's the dimension of TBL2? But there's one table in here, and that's fine. Now we've got 98 rows coming back. This is different. We've got a qualitatively different document coming back. Same structure, but more information. And if I repeated this and changed this to the 1990 to 2010, I'd only get back 21 rows, and so forth. Life is good. Okay, so it's actually giving me back a different page. Okay, so what's actually happening is every time we change pull out the start and end year and click OK, we make a request back to the web server, which gives us back a different page. Okay, we could do this all in the web browser, but it's easier for them to actually do it back over on the web server, make the request, and come back. That's what's going on. Is this clear? So that is how we actually get user-specified inputs to actually customize how the page is going to actually, the contents of the page, okay? But where it's all going to be done on the server side, not on the client side, not in the browser, okay? Because in the browser, we're in trouble. We're back to this issue of when does the code get executed? But we're still reading the HTML table. So what you've actually seen now is a way of actually doing a slightly different HTTP request. And it's still this notion of get with, and there's no body in this. The information, the user inputs come in the URL after the question mark. Okay, how do you find the names of these? By the way, the reason I put quotes around these is because poor R doesn't understand. Type start that minus year, it'll try to actually subtract start from here. Okay, these are names, so we just quote them. Okay, but that's all. This is just if they've used start dot year, you wouldn't have to quote. This is just the naming convention that they've used. Everyone happy? So, yep.
What if you have like a table that display like a long table that you have to go to the second page and that page?
Good question. We'll see this in a bit. We'll see an example of this, but what are you going to do? Let's think of a strategy for that. So for example, here's a table. Here's one, okay? This is Cyber Coders, a place where you can look for jobs, okay? I've actually already, you type in the title of the job if you're looking for data scientist, here comes. Okay, so this is a good segue, okay? Here are all the jobs, they're all kind of nice. Actually, I want to actually play with this. I want to get these, and then we get to the next page. I want all 6 pages. I want to basically take this page and pull out each job. I want to get the skill sets for those jobs, and then I want to go on to the next page, and the next page, and the next page. So how am I going to do that? Oh, you'd love to think that would maybe. So one of the things we can actually do is, so let's take a look. This is the actual, don't show me that. Okay, this is the URL. Okay, so we can try to figure it out. So there's a request being made. This is the URL, okay? And then these are the variables or the parameters that we are now put in. See the plus here? It's turning that plus, the space into a plus. Sometimes we'll turn it into %20, depending on what I want to do. Okay, these are ampersand. We can separate these out. So we can actually, there's no page here. Okay, bummer. Okay, well, hang on a second. We're only on the first page. Let's take a look at the second page. Okay, let's go grab that. By the way, now let's just, that's one. Okay, and there's the second. By the way, notice what I told you. There's the %20 for the space. In the first case, Google Chrome said, I'll put a plus in. Now it says I'll put a %20 in. Okay, so
Okay, we don't want to deal with this. This is why get form, and you actually just leave it to somebody else to actually escape these things rather than building the search yourself. Is there a page there? There's a page. And this is totally specific to cyber coders, this web page, okay? So in general, what we might actually want to do is,
okay, another approach to this is, let's actually go down here, and you and I know this. You're going to click on that, aren't you? That one, for the next page.
so what we can actually do, and I'll show you if you want, but that little guy here is actually an HTML node. It's a hyperlink, so the name of the node is A for anchor, and it's got an href attribute for the hyperreference. If we could find this guy here, okay, if we could find this guy in the HTML and pull it out and identify it with some pattern, then we would just be able to get its href attribute and then follow that directly. Like what happened?
With me as a strategy, let's take a quick look. I'm going to look at the search. This is what you spend a lot of time doing when you're scraping.
Is you go to the page you want, basically in the browser, do all this in the browser, you look at the source, and then you try to find a pattern that uniquely identifies the pieces you want. I want two things out of this, okay? There's two steps. I want to actually be able to go and find each of these jobs. They're clearly kind of in a box by themselves. I want to be able to go find them and pull out different information. I want to have a quick piece of it. I want to quickly get the salary, the full-time salary, and just have a quick
understanding of that. I want to get the skills out. This is actually very structured. And then the other thing I want to do is I want to go on to the next page. So we can easily scrape all of this information. Let's go over here, okay? So I happen to know this, which is, well, how do you do this? You wander your way through and you just look for certain things. Well, hang on a second. Let's look at the last one, which is, we want to quickly jump to this area. It's not clear how we do this. You zoom down. Oh, look. They're the guys we want.
Okay, these are the next pages.
These are the links to the, where do we go? These are the links, okay? How do you know to do this?
You have to actually, we're going to do this. If we were to write this to scrape cyber coders, again, look at the terms of service, okay? And do this in LinkedIn, and you will be banned, okay? So these are the links. This is page 2. This is page 3. There should be a page 3 lying around the place somewhere, okay? And look at this guy.
Let's go down to the end. Okay, there's the next. Okay, and then this here. See that? See those two magic little carrots? See that little thing there?
That's the big, that gets turned into the big great event sign, okay? And this here is the link to the next one. Why didn't we see the word next here? This should appear. If you take a look at all these here, it's just page 2, page 3, and it should say next. This is invisible. Okay, it's an element, but it doesn't get rendered because somebody told the browser not to render. Okay, but this is enough for us. These actually happen to be the same. These actually happen to be the same URLs. And this is the bit we want. So we're taking very contextual knowledge. This does not apply generally to all web pages. So we have to customize to a web page. This is why we want the API. Okay? But see this guy here? Next is the magic key. This guy does not have a next. It's basically saying, if I could find an anchor, a node named A, that has a rel attribute, an attribute named rel, whose value is next, I could steal its href
and be done. Okay? So let's just do this. Okay? Okay? So I'm just going to, so this is also on the web. Okay? So what are we going to do? Let's start from the very beginning. Okay? Okay, we actually know how to do this. Okay, there's our URL. We already went to the web browser. We put in data scientist. We saw what came up in the URL navigation bar. We know how to actually limit this. We know what the names of the variables are. Okay, so it's just search terms. Okay, so we're just going to actually go and say, go get this form here. We're passing in the search terms. Now this is trial and error. Do we need the other ones? if you take a look at this, it says that we actually need to specify the original search equals true, sort type is empty. Do we need those? Let's try it and see. Okay, if we don't, we can get away with it. Maybe it does, then we'll just try it and go. Well, what we've actually got now is we should have the first page. Now we parse this document. And now here's what I'm going to go straight for that next. Okay, that comes later on, but seeing as you asked about getting the next page, what I actually want, and this is the piece of magic that underlies the read HTML table, okay? And basically everything we do with HTML and XML is this, something very close to this. I'm going to say get node set on the document, and I'm going to use another language. I'm going to say give me a node named A such that it has an attribute named rel that's equal to next. Okay, let's just try it. There we go. We've got both of them. Okay, and that, and I can do a variety of different things, but that's just, I'm going to pull out the attribute named href from each of those nodes, and that's it. Okay, everyone with me? No, you can't. Okay, there should be a question. This is a whole other language. It's in R, it's in Python, it's in all these different things. There's various different ways of pulling out content for identifying essentially nodes in this tree. I've gone down basically and said, I'm starting here, and I want you to go down and search every single part of this tree, looking for a node that has the characteristics on top of that, which is, and this is shorthand, and we use it all the time. We're basically saying, start at the very beginning, the root node. Okay, // means, oh, by the way, it's actually termed, there's a thing called an axis, and in fact, the name of the axis is self or descendant, which means check yourself and everybody below you in the tree. Okay? So we're basically saying, okay, that's the direction I want you to search, which is search yourself and down below. Okay? I could also say search yourself and go sideways to your following siblings or your preceding siblings, or go up here to your ancestors. I can choose different directions. This is a language called XPath, okay? And it's a path, okay? We're basically going to give it instructions as to how to wander through the tree and pull out the set of nodes that actually match the criteria that we specify. We're basically saying, okay, go down, start with yourself and go down. Then we say, okay, the test is look for a node named A. Okay? If you find one, I need you to do one more thing to see if it's to include it in the results, and that is such that, so it's like R subsetting, such that it has an attribute named rel, and its value is equal to next. Okay, and that's it. So it will go through and it'll find all these A's that don't match that, and it'll just keep going. It'll go down through them and look at their children and their children's children and so forth. And it just collects up all of the nodes that match this criterion, and then it gives us them back at the end. That's why we got two of them. We had two that actually had exactly that. We saw that in the actual HTML. Is this clear? This is a piece of magic, because if you actually had to do this yourself, you would actually have to write a recursive function, basically say, check the name. Is the name A? No. Okay, then go to the children. So it's actually not such a big deal, but recursion really does. And you have to collect the answers somehow. You'll have to combine them. This does it all for us, and it works incredibly fast in comparison with what we would do in R. Okay, so this gives us exactly what we want. This is a thing called XPath. XPath is basically a walk through the tree to pick up the nodes that we care about. A path is made up of steps, a sequence of steps. So I could have actually sort of said something like this. I could have said, go find me. I could be more specific. If we go back over to here, okay, what do I actually want? I want this guy here. So I could have said, I want a node that is called li for list item, which has this class with link next, okay? And then I want to get the A element of that, and I want to get its href. That's if we didn't have this rel equals next, that might be the pattern I need, for example, okay? In which case I could say, go find me this li such that Okay, and then we have these little functions in this language called such that the class attribute contains, what was it, lnk next. So does that string contain this? Okay, if so, that's fine. Then I want you to go and get that A, and I want you to go such that that happens as well, and then give me the href. If I was getting too many coming back that matched, I need to make my criteria more strict, more. I need to filter some more out. This is so I can be more and more specific. I want to be as specific as possible and no more because I'm lazy. Okay, I want to just type exactly what I want. Okay, so we saw we got the right answer, but basically this is now saying here's a step, and then we may match 3 or 4 of these nodes. Okay, then from each of those, take the next step. Okay, in parallel, we'll go off and actually sort of and follow each of them separately. So this is a step, this is a step, and as a result, this is a path. Okay, everyone happy? This is the piece of magic that if you master this, you can just do anything you want with HTML and XML. Okay. It's very much a language like regular expressions in the sense it's finding patterns in places. Totally different. We don't use regular expressions for trees. Okay, this is okay, but it's a domain-specific language that it turns out to be extraordinarily small. Okay, as I say, all it is which direction and how should I travel? What's the name of the name or type of the node I'm looking for? Typically, we just use names. Sometimes you use a type like text. Parentheses, okay, and then this condition that I want to actually check on the contents of the node, not just its name, and I have these functions that actually I can use in here. And in the XML package, you can actually write your own functions here and start doing all sorts of interesting things. Everyone happy? This is XPath. Now you're done.
Is it part of the XML package?
Yeah, this is all the XML package and the XML2 package. Get node says. Take this XPath query and apply it to this thing, okay? And we can say, hey, I'm starting here, search here. So we can look at the root of the tree, or we can look down into different sub-parts of the tree, and you can do it. This has got nothing to do with R, really. It's an implementation of it in R. It's XPath, and you can use this all over the place. Okay, everyone happy? So this actually is the piece of magic. How does read HTML table work? What it does is it says get node set of table. Okay, it says go find the executable table. And then what it does is it actually goes through and looks through the TRs and the THs. So there's one other thing that can be very, very useful here. So if we just go off and do this, it's useful to know, instead of actually getting back the hrefs, I'm actually going to get back, let's say, the nodes. Okay, type. Okay, so gave me an error because I said, oh, and the next step is this, but I can repeat the next step. Okay, so we now have this. These are the actual nodes. So it can be very useful to actually know that there's a couple of functions in R in the XML package. Okay, so if we call this n equals this guy, and I'll just get back the first guy. That's the node. It kind of looks like this. Okay, I can actually go in and say, okay, what is the string? What is the text inside this node? That's the text. I can say, get me the children of this guy. Okay, there's only one in this particular case. I can say, okay, well, give me the parent of this guy. Okay, so I could, if I want, write the function to recurse through this tree, but I can use XPath for that. When I get the nodes back, I can interrogate them and extract information, and I can also just basically say, okay, give me the attributes of these guys. Okay, give me the attributes of that thing, and I get back a character vector, and I can pull this out myself. Okay, so there's a couple of functions in here that in the package. The most important one in my mind is get node set. That gets you getting the nodes that you care about, and then you can go in and tweak them and play with them and pull out different pieces of information. In this, we could literally spend the next day talking about XPath, because I said that if you understand this, if you can get used to it, this is what we do all the time. We are finding patterns, okay, and we're trying to find patterns and then apply them to a bunch of nodes. If we were, for example, trying to actually this is a thing. The key thing is all HTML documents are different. So what we actually want to do is we actually want to go take a look at a sample one. Go find the pattern that we need to identify into the data that we actually care about, and then go and see if it will apply to the next page. And if it doesn't, go back and actually try to find something that is common to both. So this, we spend a lot of time doing this. And if you look at this, we'll go back to the very first page. Okay, suppose I did actually want to get out the wages for these things, and I wanted to get the skills. What I kind of need to do is I need to figure out where they're located. I can just open up the page source in the web browser and take a look. I can do that. You saw it's actually quite tricky to go find the next one, because it doesn't have the word next in the text that I'm looking at. One of the things I could actually do is this. I can look for this. I can look for something that says, okay, show me, get node set on doc, show me any text that contains that. Okay, 120K. Okay, that's, what did it not like about that? Sorry, let's just check. Type. Okay, so this, okay, by the way, this dot means walk your way down, and when you're going to apply this condition, means use the current node as the value. Okay, so it actually it dynamically knows where it actually is. Here we actually find these guys. So how would I actually, I do this an awful lot, okay? So here's what I want to do. Let's do this, which is n equals this guy. Just give me the first one. I'm going to assume they're all the same. Why? Because this is machine generated. There isn't a guy sitting there typing the response to your query and then deciding to stylize this in a slightly different way. These are all formatted in very much the same way. So if I do the following, if I look at the parent of n of this node, there we go. That's why I knew if I wanted to get the wages out, I'm going to guess a pattern. The pattern is that there is a division. We use these an awful lot in HTML. There's a division, this kind of generic concept of a block. Okay, which is a class whose value is called wage. This is a class attribute, and now we can go and actually pull the content out of that. Okay, so if I believe that, then maybe that's I can go and apply that. If I actually go up one more, we can see, okay, look, this is the details of a section of this job posting, and if I go up one more. Okay, then I say, okay, now I get the job skills, and now I get this sort of thing. Hey, look, there's a division which has a suggestive name called job details container. And I bet you there's probably a bunch of those, one for each job. And now what I can do, I can go find that block and then go in and pull out the different pieces that I want. Is this clear? Do you all know how to do it? Well, it's actually, how do we do it? This is okay. If we actually wanted to do that, let's do. Okay, what was it called? Let's go. This is as I say. This is one of the most important parts of it. Is what is the process? Not how do you use XPath, but what is the process by which we use it? So let's go get node set on the document that we pull down through get form. Show me all of the divisions such that the class attribute is equal to that. Oh, that guy. Okay, so we write this, and now what was that thing again? Okay, it's job details container. Okay, that's the guy we want. So let's call these J for jobs. What's the length of this? Oftentimes we get nothing back, it'll be empty. But this got 20 back, and there's 20 on each page. Okay, so we actually have every single job on that front page. Now, we also know how to find the next page. So we can now go through and scrape all of the jobs for our corresponding query. And now what we need to do is we basically need to take each of these J's. So we take a look at, and let's go and get the, let's do this. Let's go and get the skill name here, okay? Underneath this, get node set on the first guy. And now I'm going to start at this guy. This is a very unfortunate, annoying issue, okay? I'm going to basically go do it, and I'm going to say, go find me every span such that the class is equal to skill name. Happy? That's just on the very first one. Okay? And that's what we get. We get those three guys back. And what I'm going to actually do is one other thing. Now these are nodes in R. I'm just going to say, give me the value. Okay? And now I've gone from HTML, now I'm
and I have HTML. I need text here. Okay, so what I can do is I can go put these into a data frame. I can do whatever I want. I've done this. What have I done? Get node set to find the nodes. We use this to find jobs first, the containers. Now I'm going to loop over each container one at a time, okay? And then I'm going to start searching from there down, not from the top again, but from there down. So I say, hey, anchor yourself where you are, start where you are, and then go down. Do not go back up to the rooted document. If you notice what I've done here, and again, this is one website. Well, it's not really, okay? A lot of people use this idiom of basically it's div or stan or something with a class that we care about, because they're using this to color code and to render all the same elements in the same way, in the same type of elements. So we were always going to go find this. So what do? We basically went in and zoomed in using get node set to say, I can see a piece of text on the screen. Go find me all the examples of that. And then walk back up the tree to see where does it stop, basically to define a single self-contained unit. We actually walk back up. We saw, okay, we have details. And we got up all the way up to the job details container. And if we went one step higher, we find all the jobs. So we want to go back and say, that's the bit that uniquely identifies each job. And now we basically go through and start finding the pieces on it. Everyone happy? That's the strategy. Okay, it's royal pain. And as I say, remember I said don't scrape? Because if somebody, their web page designer, okay, and their database guy, okay, are all involved in creating this page, and one of them decides that he's going to be creative, okay, and he's going to change this to be skill name, he's going to change it to be skill identifier, and your code breaks, and you got to go through the process again. Okay, so if they decide that they just want to be aesthetically more pleasing, okay, and that they don't actually, if we look, they put skill name, so it's not that it's equal to skill name, literally they just put in an additional class name. We have to change this to be contained skill name. Okay, so it's very, very brittle. Okay, but fortunate enough, people don't go around changing this very often. Okay, but if you want to do this and you want this to run for a year, expect breakage. Okay, any questions? No. Now's a good time. I'd say there's a lot. Yeah.
Just you were talking about finding that specific piece of text that you could see on the screen, and then when you're walking back up. And was that the process of using the XML parent?
Exactly. And you could, if you want, you can just open up the page in your web browser and look there. It's just sometimes that's huge, and you go like, I don't know where to start even looking. So, and you can search in the web browser for that text and then look around, whatever's most convenient. Both, but the critical thing is trying to find the pattern that you're looking for, and then seeing does it apply across other nodes.
Because you sort of iterated 3 times to XML parent.
How did you know
this? Where do you know to stop?
Years of experience. Unfortunately, this is the art of it's like a regular expression for pattern matching. You basically say, how specific should I be? Except you don't want to go and find everything because that's too much, and you don't want to find nothing. And so you want to find just the right amount. And there is, so you've actually got to look and sort of see. Here's one job. So I mean, this is literally what I did this yesterday. And, you look here and you say, okay, let's go look for Naperville. And now you look for McLean and you go say, where is it similar? Where does it stop being similar? Where is it similar? Okay, and then that's the cutoff point. So XML parent up to how far do you go? And another example I've written down, you go 2 and it gets it exactly right. In this case, it's 3. Another case, it's 4 or 5. Okay, it also depends on how nested these things are. Okay, but basically we can go and pull out all of the information from here. Okay, what is it? What have we done? Get node set, and then just a few of these little functions called XML value, XML get error. Okay, maybe the parent or the children. Okay, and we're done out of there. Okay, everyone happy? I say there's way too much to learn in this in one sitting. Basically, get node set. XPath is your friend. It turns out there's a nice O'Reilly book on XPath. Okay, XPath and XPointer, I think it's called. Okay, the funky thing about it is that it's a very short book. It's about 70 pages, and honestly, there's about 20 pages on it that you actually need to understand. It's the shortest description I've seen that actually really does a good job of this. If you
I put up some resources too. If you, I can't remember. I think it's called XPath and XPointer as the actual text. I'll search in a second. Here's another example. Okay, this is the W3 Schools tutorial. An excellent resource to get started. My point is, there's almost nothing in this language. It's so powerful, and yet it's extremely simple by design. And it's just, once you get this notion of what the computational model, so it has these things, and if these are these axes I was talking about, these are the directions. This is ancestor or self. So look at yourself or go up. Descendant or self. These are all axes. They tell you the direction, okay? But there's also shorthand for these. I'm using // which means descendant or self. Dot means a parent. It's very much like a file system. If you're used to navigating the file system on the command line, it's very, very similar, except for it's way more powerful. And so, but once you understand, I have to specify direction, then I specify a node name or type, and then I optionally put in these conditions. And there's a couple of functions that you can use, like contains and equals, and other things, substring and so forth, that allow you to do very, very powerful things, okay? There are, by the way, you'll see other people recommend that you might use something like, which are called CSS selectors for finding stuff in HTML. The reason I'm telling you about XPath is it's actually more powerful. And secondly of all, we use it in XML, whereas the selectors don't work in XML to the same extent. Okay, they're very much an HTML sort of concept, and so and I like to learn one thing that's super general, but other people like to learn lots of smaller things and try to keep them all in their head. I find that hard. So that's fine. Did you find that? And this was the name of the book, I believe. So that's it, and it's gotten longer. Okay, there's an even shorter version of this. Okay, but my point, there's lots of books that have this sort of stuff. The point is, it's extremely short, and it's very well worth looking at. Okay, let me just see where else I wanted to go. Okay, so we've done XPath and all this sort of thing. So basically, I say this to me is absolutely everything. XPath is absolutely everything. Let's go into here. Okay, let's just take a look at this. Here is a web page. Where are we going? Okay, so this is an annoying web page, but that's okay. Depending on our need, there are times, by the way, the other thing is, don't bother trying to actually spend 3 weeks constructing a programmatic solution. You can actually go and download the data yourself by hand in an hour. Okay, obviously do the right thing. Okay, so what you actually do here is this, and it's already remembered who I was. What was that? What did we just say? So it's 45201, was it? So we'll 45203. Let's put in. Okay, we put in zip codes. Okay, this is electricity data. Okay, okay. It's basically how much you can charge per kilowatt. Okay, and he wants to actually pull this from the entire country by zip code. Okay, because it's kind of interesting to see what's going on. And they actually have different offers, different rates that you can lock yourself into for different times and so forth. I believe this one will actually say, hey, you can lock yourself into this and we'll give you Amazon Prime for a year for free. It's like, really? This is, come on. Okay, so what we do is this is what we do. This is what you actually have to do. There's another thing I need to get to. Sorry, sorry, just let me do one thing. I want to, how did it get moved? Let's just do this one. We'll come back to that in a second, because this, when you get into this, it's kind of funky, but it's, sorry. So let's just do this. I want to show you this because this is the other survival trick that we use. Okay. So this is truly ugly, but we can actually get around it. Okay. So this is the nice one that looks really hideously ugly. It looks better, and yet that one causes This one thing. So what you do, this website drives me absolutely ballistic. What you do is you go over here and you pick. Okay, so then you move. Oh, Mr. Oh, Mr. Oh, it's like, good grief, just leave the stupid thing. Okay, so you have to carefully navigate your way down to make sure that they're still in there. And what you do is you type in the name of the zip code number. Okay, for it. So you can pick a region, and then, or you can just put in a zip code, and then it will go off. So let's change this. By the way, just to back up a second, we want to go through every zip code in. What's this? It's like 750. I've lost track of it. So maybe anyway, we want to go through every zip code in Texas. I need a list of zip codes, valid zip codes. I'm not going to just try arbitrary ones. How do we find them? We find them on the web, and we just read HTML table. We got them all, and then we loop over all of those guys. So we can we're combining all of this information together. What you do is you click on this thing, then you go down to here, and it then says, nope, I don't know how to do that one. We don't service that. So now we click back to form, and so what was it? 7502. 002. Okay, and did it actually do anything? No, there we go. So I think it actually updated itself, but basically this is what we actually have to do. We have to type in the zip code here, and then click go, and it will then go off and give us the actual details, either for that zip code or for a general one, because it doesn't even know about that zip code. So it's kind of a weird. Is this the way we want to get our data? If it's the only source, yeah. Okay, but God, this is worth weeks finding an alternative source rather than actually going and dealing with this. Anyway, so we can kind of actually do this. I actually claim that I can do this without pointing and clicking. Okay, and here's how I know. Okay, and this is a piece of magic. Okay, and we should. Okay, what I got. Actually, I'm going to just do this. I'm going to choose to be over in Firefox. Okay, I'm going to open up a new Firefox window. Why? Why not? Okay, because Chrome was doing something weird for me. And anyway, now we're over here. Okay, so what I'm going to actually do is I want to watch what the web browser is actually doing, not what it shows me, but what it's actually doing. So if we go over to here and we go into if we go down to here, okay, it's different for each browser. In Firefox Tools, Web Developer, Toggle Tools. How many of you have ever done this? Okay, not just a few. This is interesting. Okay, so we still got our page here, and now we're just sitting here looking at this. We've got all these different tabs here for debugging the JavaScript and looking at all sorts of interesting things. I'm interested in the actual requests, the HTTP requests. Remember, we're going to fill in this form, click go, and then it's going to go off and do something and get a page coming back. Okay, I need to mimic what it's doing. If I can mimic it from my life is a lot easier. So now what do? We go over here, we click on this. This is too big, so I need to actually resize this a little bit. I go over to here. I'm going to go over to this guy. I'll change this to be number 1. And I click go. Now, watch what happens here. This is all of the web requests it's making from that one little page. Okay? Okay, we can go back here and actually scroll our way back up. See how many requests it made? See why the web is slow? Okay? Okay? That was the original request. Okay? That was the request my browser made, which then spawned all of these additional requests. This request is actually quite interesting. It actually failed. Not quite failed, but it didn't succeed. These are all successes, status 200. This is a redirection to another page. Okay, maybe another website, but either one, it actually doesn't matter. It just takes care of it for us. We can take a look at either of them. Hey, look what we've got here. We click on the request we care about, and we end up with another window with tabs. Here are the headers. Here are the cookies. Okay. Here are the parameters. That's the guy I want. Okay. Okay. So here's what we look at. Here's the response headers. I couldn't care less about the response headers. I care about how did the browser make the request? Okay, these are the headers we saw flying by when I said get URL content with verbose equals true. These are the same headers we can put into our own things. Nothing looks particularly interesting about my 75001, the actual zip code. Okay, this is a post request. Have I mentioned these before? They're almost exactly the same as a GET request. So remember, we had a GET request, which is we just give it the URL. Then we had a GET request where we actually put in parameters from the form, which is start here and end here, but we tag them on to the end of the URL. And a post is just a more intelligent version of that. The post takes the parameters and puts them into the body of the request. And this is a much better thing to do. Why? Because if I want to send you an image, a nice big 2 gigabyte image of a picture, I cannot put it on the URL. It's too big. Okay, it's a limit to the size of the URL, so I can't just tag anything in. Whereas I can put anything in the body, and I can get anything back in the body, no matter how big it is. So post is this way of actually appending extra information to the request in the body. Do you care? No. Instead of calling a get form, you're going to call post form, and you don't care how it gets done. Okay, it's exactly the same information. Okay, but what we do need is this. We need to know what the parameters are. I'm looking at this going. So let's look at this guy. Okay, this is interesting. Okay, this is actually fun. Okay, so these are the parameters that were getting sent by my web browser to make this request when I typed in the actual zip code. Is this clear? Now you know how to actually make this request. Okay, and this is, again, years of experience makes this obvious. Okay, but this is the magic trick that says, I want to know what they're doing, what the browser is doing, so I can emulate it programmatically in our pipeline. Well, let me just ask the browser to show me all the details. So we click on this, we find out the headers, the actual fields in the header. We check and take a look and see, are there any magical ones there? One of the magical ones is we never sent a user agent. Okay, if we go back over here, I'm just letting you know this because it is very, very annoying. Over here, this is the response headers. We don't care about that. See this? It says, hi, my user agent description is my Mozilla 5.0 on Macintosh, and this is the actual build. Nobody cares. Sometimes they do. If you don't put a user agent in there, they go, I'm not answering you. Even worse, I'll give you back an empty page, or I'll give you back my generic page. Okay, sometimes you really have to mimic exactly what the browser sends. We should be sending the user agent is R, okay, or the R package or the R functions you're using, okay? But sometimes we actually want to pretend, hey, I'll pretend I'm Mozilla, because you'll only give me the right answer if I tell you I'm Mozilla. So we do actually have to mimic the headers sometimes. This is trial and error, but again, you're trying to amortize this across a lot of different things. And then what we need to do is we actually need to send all of these as main value pairs, okay? And then that will be enough for us to get this. So if you actually take a look, no, it's actually somewhere else. This file got completely messed up. So basically, I'll just show you. This is the request we make. That's the URL. I typed all of these names in myself. I cut and paste them and I just fill them all in. I probably could omit some of the empty ones, but I'm not taking any chances. I'm doing exactly what the browser says. I do this, and then I basically say, oh, by the way, I'll just mention this down. Throwing stuff out so that hopefully you'll remember to ask about this. I basically say there's two forms of the body. Okay, I can represent all of these in two different ways. With the question mark, name equals value, ampersand, or I can actually use a different form, which is called form encoded, URL form encoded, which is the way everyone wants it to be. So we just say, this is the style of posting. Okay, and by the way, I use this other little trick here, which is another useful thing to know, which is, if we go up to here, one of the things we sometimes do is this. We say, hey, go make a connection to this URL and keep it open. This is like a telephone where you basically make a call to the website and you basically say, I'm going to have a lot of conversation with you, maybe only 2, but keep the connection open, okay? So basically we say, I'm going to create this connection, and then I'm going to use it to make the initial contact. And then I'm going to use it in all subsequent requests for that host, for that machine, the web server. And one of the reasons for this is they will actually, if I turn on the cookie jar, okay, they will send me cookies, and I will promise to give them back when I make a subsequent request, so they will remember who I am. And some of them will say, hey, you didn't come in the regular way, I'm not answering you. Whereas if we come in the regular way, remember the cookies, and then send the cookies back, which we don't have to do. Our kernel package takes care of it for us. This is good, but this is actually keeping the connection open across calls. It's actually faster and as well, which is a benefit. So basically, this is how we do this. Okay, the takeaway message here is, let's see if we can mimic the browser. Okay, we can't always, because we'll see an example where we can't mimic the browser. Okay, but if we can, we just go and find out what the requests it's making, and then actually go and implement these. All we're going to be using is post form, get URL content. There's the only 3 things you basically need, okay, to actually make all of this for 99% of all of the requests. Then what's happening? We get back an HTML document, throw the browser away, we disconnect from the internet, okay, we parse that document and then pull out the content that we actually wanted, which was whatever it was these guys. Okay, so now I can go in and find my 9.7 kilowatts per hour. I can go find that value and I extract and I walk away. And then I try the next zip code, and I try the next zip code, and the next zip code, and so forth. Okay, life is fine. Now, where were we? It was the other one that okay, so this is the, okay, again, I know I'm hopefully you're picking up the ideas and the concepts. The details are extraordinarily frustrating. Why are they so frustrating? I'll tell you why. You get back an answer, and you have no idea what's going on in the web server. Okay, so you try something different. You try a different user agent, and you basically guess as to what it's basically. I've got a secret. You have to find the magic call. Okay, this is why we use the browser to actually figure out exactly what was successful and then try to mimic it. But an awful lot of things can go wrong. And so this was this hideous web page. Okay, so this is the part of the problem here. Okay, so I type in. I'll just try this. Okay. So what you actually do is this. You open this. It remembers who you were, and it remembers the old value, which is really annoying. Okay, because it's using cookies and storing stuff. Anyway, that's fine. So basically, we click on this, and we say change. If you start from scratch, if you went to this page, it would just say enter the zip code. We click on this, and then we click enter. And one of the things we could try to do, okay, now what happens is we click on enroll now. Okay, so we first of all have to put this in. Like, why it doesn't automatically enroll us, I do not know. I think it's just here to annoy me. Okay, and now we click on the enroll now, and then it goes off and gets the page. Now, okay, now we've got to click on hello. Which one? I want electricity and I want Duke Energy. Okay, and then show me the plans. Okay, now, if we want, we can actually open the browser tools and see what's going on and try to actually mimic this. Well, this is just one example. There's many examples. There may be a good way to get around this, but I'm using this as an example. What we actually really need to do in general is this goes back to the fact that there is JavaScript running to actually control all of this. Okay, we don't have JavaScript in our, okay, we kind of do, but we don't have the browser's JavaScript. We actually need to emulate the browser, not the browser's requests, but the actual browser. So how are we going to do that? How many of you are undergraduates? Okay, so you employ these guys. Okay. So you can do it manually, but we don't want to do it manually. Okay, so there's a trick to this. Okay, some people have written some very nice pieces of software, which is we can remote control a browser. Okay, what we basically do is we actually program instructions to say, load this page, click on this button, insert this text,
click on that button, and then get the page, and then give me the page. Okay, with me? This is, to me, when all hell breaks loose. This is your worst nightmare. Okay, well, I said don't scrape. Nice static pages, great. Okay, get forms, not too bad. Posting forms, just the same. Life is great. When you're in here now, oh, good God. Now you really are at the mercy of literally clicking on buttons that may move and change around. Okay? I'm going to show you a particular thing. There's a variety of different approaches to doing this thing. Many people have sort of converged on this thing, and it's a little okay. And there's a script here that actually goes through it. I'll show you this in action if you care. There's a piece of magic that we're going to have to actually run first. So let's actually do this. Okay. Do I actually have it? Which is minus D. There we go. I'm going to run this piece of code. Okay, so this here, I'm in the same directory. This is all fun and games. You do this once, okay, it's fine. Okay, so you download a bunch of stuff. You download a jar file, which is a Java archive file. Okay, I also downloaded 2 drivers. We only need one, but I'm putting into. We're basically saying, okay, this is how you talk to Firefox. This is how you talk to Google, Google Chrome. I run this, and it basically says, okay, fine. What I've actually done on my local machine is, okay, there's an application running here, which is called a Selenium server. Okay, and it's going to wait for instructions from me that I'm going to give through R, Python, or something like that to actually drive a web browser that I'm going to see. For those of you who are familiar with a Mac or tabs like this, you see this? I got Google Chrome and I got Firefox. You see those two guys here and here. Now I'm going to go back over to R. I'm going to go back over to here. I'm going to load up the Selenium package. I've just started the Selenium server. I'm now going to connect to this guy, and then I'm going to actually say, hey, give me, and hopefully this will work, give me a new version of Firefox, a totally new browser. Okay, so just to clear, there's my new Firefox. Most people don't get to see 2 Firefoxes here. We've actually constructed 2 totally separate Firefox browsers running independently of each other, and they don't know about each other's histories and all that sort of stuff. Okay, it's as if you're a different person. Life is great. So let's actually go take a look at this. There it is. It's got a nice little icon that says it's being remote controlled. Okay. Okay. So it's sort of saying this is not your regular browser. Do not go start doing things here because you've lost. But basically, what we're going to do is we have a bunch of commands that we can issue to this thing, and we basically say navigate to this, and you see it. You saw it go off and start thinking. And it went off and just doing exactly what we're telling it to do. As if I type that in the browser, I still can. Okay, and now here's the thing we actually want to do. Okay, again, you're going to have to actually sit there. I'm assuming here completely that it is worth your time to spend 2 hours or an hour or 10 minutes, depending on the problem, to actually find the pattern and then implement it so you can amortize this across thousands of calls or whatever it is. Okay, so what we're going to do is we're going to go off and look. Remember, what we need to do here, and notice, by the way, it didn't have my zip code here because it doesn't remember me because I'm a new person. So I need to go and find this text field, and then I need to send it the zip code. And then I need to find this enter button and click it. Okay? I told you this is ugly, but it's beautiful because you can do anything now. Okay, so basically, what are we going to do? Well, here's the magic trick. If we open up the HTML source for this, you will go through and you'll go and look for enter zip, because that's the magic text that we saw, and then you will look around and see what's there. So let's actually do this. Okay, so now I'm going to switch to my other browser just for fun. Okay. So now if we do this, we look at this, we look here, enter. So we start looking down through here. Come on. So much nonsense. There we go. There's the enter zip. Now where'd you go?
Okay, so this was so we went and looked at this. This is an HTML form, it's a form with these input types and how to submit the form. We saw this enter zip, that's the placeholder text. That was how we went to search for it. Okay, and basically, what do we want? Hey, look at its name. Its name is zip code. That may or may not be unique. You can go use get node set to find all inputs whose name is, who has a name attribute and zip code. Okay, if there's two of them, we've got a problem, but we are guaranteed that the ID is unique. Okay, so let's take that ID. Okay, when we say guaranteed, it's not actually guaranteed. It's just intended to be. Okay, so now what we do is this. We basically go and say, and now we're not going to use XPath to find this node. Why? Well, because we're not actually we don't have the document. It's actually in the browser. Actually, we can use XPath, or we can use an ID, or we can use a name, or we can use CSS selectors, because it's going to do it for us. We just have to tell it what method we're using to find the object and what the criteria, what the actual query is. In this case, it's simple. I'm using the ID. Go find me the ID, the HTML element in this document which has this ID. Okay, and it comes back and says, okay, I got it. Okay, so if we actually run that piece of, there we go. It said, I found it. This is the same thing as us doing this in R. If you sort of say get node set with any node whose ID attribute is equal to this, the same thing, but we're doing it over in the browser. And the browser comes back and gives us this handle to literally this text field. So now we say, hey, send it some keys. Okay. The keys are in there. See, no hands. Okay. Okay, I can change, I can do whatever I feel like here. I can emulate a human being. Okay. And now we basically say, okay, fine. Okay. Well, now I say basically, okay, then I basically go over, same deal, go find the enter. Okay. Okay, this is really annoying. So we go find the enter. Okay. Okay, so we do that. Take a look. Did we find something? Yes, we did. Okay, now we basically say, click on it, please. Okay, notice now it switches to enroll now. Okay. Okay. As tedious as this is, it's going to be a lot better than us doing it manually. Okay. Okay, because now we basically go and say, okay, off we go. And now I don't quite know how to actually find. I could look in there, but I'm now going to say, hey, go find an anchor node whose text is enroll now. Because then I can click on that's the one I want to click. So now I'm using XPath. But I can use different selector methods. I can always use XPath if I want, because then I only need to remember one thing. And now it clicked. And now it's thinking. And here it comes. And now we've got our answer. Okay? And now I pull this up and I write down the numbers. Okay? Now I need to do the four things. I'm spoiled for choice. I can actually go in and ask it to find the 6.09, this sort of stuff, by using XPath. Or what I can do is say, you know what, I don't know much about Selenium. Here's what I'm going to do. I'm basically going to say, I would like to be back in R, please. Could you just give me the current contents of the document? Okay? And it does this, and now I can HTML parse this. Now, the nice thing about this is, if it has gone off and done all sorts of wonderful things to populate this page, it's gone off and connected to all sorts of different machines, pulled the extra data and drawn nice maps, they're all now here. Okay? They weren't in the original HTML document. They had to get built by the web browser. We didn't want to be a web browser. But what we've done is we say, web browser, do all the hard work, and then just give us the resulting content. Okay? And now we're done. So this is, to me, I rarely use this. Okay? I'm lucky enough to not have to scrape things that are so dynamic. And why? Partially because I don't bother, or because I really do spend a lot of time trying to find alternatives, okay, to get that data. Because this, I mean, I said that HTML is for humans to read. This is now that on steroids. This is for humans to interact with to get the answer. Okay, so basically, this will get us the information that we actually want. We pull it back. We now have all the same tools we talked about before, namely XPath and ripping this apart. One might think there's one other example I was going to show you, and I wrote it down, so there's more details here, okay? There, so we actually, instead of just the numbers here, I may actually want this information, okay? And it's clear, you know, there's a title, and then there's a value, title, value. There's actually, these are marked up in the HTML as being title, value. I put up all the code to do this sort of stuff, so you can actually go and play with if you want. So it's a nice exercise in XPath to just pull these pieces out. I'm using some of the XML value and XML children and stuff. Very, very simple. One of the important things is, in some cases, when you click on this, it will go off. Your browser will go off and actually make a request to the web server, and then update the page. And maybe not just may not update the entire page. It may just update a small portion of the page. In which case, we have to emulate that too. But in this case, this information was just already in the page. It was just hidden. Okay? Because it happened so fast. And if we wanted to, we could actually look at the developer tools and see, no, there's no request. When I click on this, there's no request, which means it must be already in the page, which means we can extract it out of that page. Okay? And there's one other thing. Okay, so in that case, we don't have to make another request. Okay, we have it here, even though we can't see it, it's actually there. And this brings up another case, which is sometimes the content, we may go and get the page, and then if we look in the HTML, there is no 6.09 or anything like that. It is magically created, the table or whatever it is magically created as it's being rendered. Okay, that's fine. That's great. That's dynamic content, and then you would use Selenium. Okay, you have to do this automated thing. In that case, it's just visit this site and then just give me the page. There's no pointing and clicking. It's just giving the page, and that's absolutely fine. However, if you don't want to use Selenium, I mean, I can pull up the example, but just in the interest of time, this is something worth looking at. Okay, is take a look. Is just open up download the page in your browser. Look at the HTML source and see if you can find any of the values that you're looking for in the text. Okay? Okay, and what's actually, there's one example that I have on the site. I can get into more details if you want, but I'm conscious of time. Also conscious of it's basically this. There's one little trick, again, just because I like to try to keep things as simple as possible. You have all this HTML stuff lying around, and you also see these scripts and stuff like that. And in there, in some of these pages, as I said, the key thing I'm talking about is the page does not have an HTML element with something like B and 6.09, okay? But magically it appears, and if you actually look at it, it will be there later on, but it's not there when you get it from the web server. Somebody has to actually build this, dynamically construct the HTML. Sometimes, as I said, they go back and ask for individual cells, and they update the cell, okay, in multiple asynchronous requests. But in many cases, what they do is, in here, they say var d, or whatever it is, equals curly brace, square bracket, square bracket, square bracket, all sorts of nonsense, curly brace. Okay, and this is the magic piece, okay? Okay, that is JavaScript code, where we're defining a variable named d. R for here's a variable named d, and here's its value. Well, okay, here's a piece of magic. Okay, okay, if you can find the text, if you can find the values you're looking for in there, we can go pull out the script element, remove the var d equals, remove the semicolon at the end. Okay, and we have got a block of text which is JavaScript code. Okay, so we do a little bit of massage. Get node set off the script. Got that. Tiny bit of cleaning up of the text. Okay, gsub to get rid of the begin and the semicolon. Easy. Okay, and then we just do this magic piece of code in R Python if we want of the value. Okay, the string text, the text value. Okay, the text value. So we've gone in, found this text like is JavaScript code that defines the data I want. And then with this command from JSON, it takes the text and turns it into an object with all of the correct data. Okay? And now
we're in business. Okay? That means you don't actually have to go off and actually use Selenium to actually do this. And there's some notes there. It's very simple things. Just because I like to think that the simple versions of APIs are very, very simple. Okay, and then when you get into authentication, it starts getting complicated. And if you have any questions, I'm more than happy to entertain them. Okay, and we can talk about it another day. But we use JSON, JavaScript object notation, a lot for web APIs. Okay, where basically we say, we make a request, we put in the parameters we want, we get back some JSON. Okay, which contains the entire result. You don't have to don't set or anything like that. It is what we want, and we just call it from JSON and we keep going. Okay, and web APIs can be that simple, where basically you just put your parameters into get form, get the answer back, convert the results from JSON, just exactly like we did with HTML parse. You convert the text of the request response back into an R object, and then you start using it. Okay? Any questions?
Yes.
What would happen to all the 400 address in the long term?
Hopefully they're going to be gainfully employed somewhere else. So if the trick is this. Is if they know how to do this,
this is the sort of catch that gets taken. Okay.
A more serious question is, how would EDLS, like Cloudflare, detect EDLS services?
Yeah.
Cloudflare will detect all of these requests coming from the same IP. They just
Yeah.
they hear the button say, hey, what
Yeah.
are you doing? You're not.
Yeah.
Is there a way to go around it?
Turn on. The answer is there's terms of service and you are obligated to comply with those. Okay. One way to do it is to actually just go slowly. Just put sleep in. Make the request and then just go to sleep for a second or two, make it look like a human. Another way to do it is to actually use a lot of machines on different IP addresses to actually emulate this.
So we're creating zombies.
No. You're in control of them. I mean, you're in perfect control. These are you're just parallelizing this. And there is a mechanism by which I believe now it's trivial, but where you can actually make your own one machine that you can actually make it look as if it's got 255 IP addresses, so they can be coming in as different machines. But the answer is, you have to be careful about what you're doing. Okay, and they will pick it up. Depending on who exactly it is, and if they care, they identify you quickly. We can mimic that. We don't log in. We basically remember, if you're logging in to a website, you're going through a form. So we can mimic that. Okay, so remember, anything we can do in the browser, we can pretty much do in our Python or the command line, except for interpreting the JavaScript code. But as long as if all they're doing is like at the end of the day, when you log in, you send your password and your login and password, and then basically they give you back a cookie, and that is all going through just an HTTP request. And so you just emulate that. Okay, straightforward. We do it all the time.
And the API calls and just.
I never heard of it. I don't know a word. Yeah. No. I'm much less worried about the FBI than actually lawyers. Any other questions?
Thank you all for coming. There's a sign-in sheet, so make sure that you go ahead and sign that. And our schedule for the rest of the quarter is up, and you should be able to register for the rest of the series starting on Monday. Hopefully, we'll see you back here, and have a great weekend.
Stay safe.